Good morning, guys. Welcome to Science. Today, we're going to talk about some potential and kinetic energy and how you can make a chain reaction and how energy is transferred during a chain reaction. So, this is going to be a pretty cool mystery for us to explore today. We're going to be answering the question, could you knock down a building using only dominoes? Knock down a building using only dominoes. Sounds pretty impossible, right? Well, let's check out the mystery to see if you actually could knock down a whole entire building using only dominoes.
Hi, it's Doug. Have you ever accidentally knocked something over? I'm sure you have. We all have. But have you ever accidentally knocked over something really, really big? Some years ago, there was this forklift driver who was working in a warehouse in Russia. And let's just say he did not have a very good day. All of this was caught on camera. Watch what happened. Amazingly, he was okay. No one was badly hurt. But it's incredible to see something like this, isn't it? How could something like this happen? Well, you probably noticed he bumped first into one side of the shelves pretty hard. So hard they fell over, and that knocked into the other side of the shelves next to them, causing the whole thing to collapse. The way that one thing knocked over another, and then another, and then another, all of this might remind you of lining up a bunch of dominoes, if you've ever done that. It's a similar situation. You line them all up, and then if you bump into the first one, they all go tumbling down. Stuff like this can be so fun to watch. Check out this example. This was at a library using books instead of dominoes, but it's the same idea. Watch. They line them up and they just keep going and going and going, all from one little push at the start. Now, sure, one thing bumps into the next, but why do they keep going on and on and on for as long as you've got them lined up? For example, say instead of books or dominoes, we lined up a bunch of little marbles. You push the first one into the next, and the first few marbles will bump into each other, but eventually they stop. These two didn't get bumped into at all. So marbles don't keep going if you push them, but when you have a bunch of falling dominoes, why do they keep going for so long? There's not something special about dominoes. It works just the same for books, even for lockers. Watch. Now, as you might imagine, what matters to having things like lockers and dominoes keep going is that things like lockers and dominoes and books, they're all objects that can be tipped over. And that means that each one has to be set upright. You have to lift each one up. When you do that, you're putting part of each domino up high. You're giving it height. Does that remind you of anything? Can you think of any other situation where something is put up high and that does something special?
All right, guys, so you're thinking about what's a situation where you're putting something up high? Well, one thing that comes to mind to me is that I know we've talked about, boulders or rocks that are at the top of the mountain. And when we talk about when they're at that top and they're sitting there on the top of the mountain, they have a lot of potential energy from being up high. They have the potential to fall and turn into kinetic and moving energy and fall down. So think of in terms of energy, how giving that height can actually give that object some more energy. Let's check out their little hint of what they came up with. Oh, so think about things you've seen in an earlier mystery. Well, like yesterday, we looked at the bowling ball and we lifted it up, and that gave it some potential energy and gave it some height as well.
When you set up a domino, you're putting part of it up high. Does that remind you of anything? I hope it reminds you of the idea that putting something up high, giving something height, is one way to store energy in it. One example we've seen in previous mysteries was a roller coaster. By moving a roller coaster car up to the top of a very tall hill, you store energy in it. Energy that gets released as the roller coaster car rolls along the rest of its track. With dominoes, you have to set them up, you have to lift them. Some of the energy you use to lift them up gets stored in the domino. So with this in mind, why is it that when you knock down a row of dominoes, they just keep going and going? Well, the reason it just keeps going is because when you set them up, you gave them height. So you stored energy here and here and here. You stored energy all along the way. When you push on the first domino, at the point that it begins to tip over, you release its stored energy. And as it falls, it transfers some of that energy to the second domino, enough energy to tip it over. As the second domino begins to tip over, then it releases its stored energy and transfers some of that to the third domino, which tips it over, and so on, all the way down the line. This will happen for as many dominoes as you want to set up. It's fun, and you're probably dying to go play with some dominoes right now. But let me get you to think about something even more surprising. Now, so far, we've just been considering dominoes that are all the same height. Does that matter? Will this only work if they're all the same height? Like, what do you think would happen if we had a normal-sized domino next to a really tall one? Well, there's an easy way to find out. Let's try it. What do you think is going to happen? Make a guess in your head right now about whether or not you think the tiny domino can push the big one over. I'll give you a few seconds to think about it to yourself.
What do you guys think? Is it going to work?
Okay, are you ready? I'm going to go ahead and do it now. Let's give it a push. Nothing, right? The small domino had some stored energy from being lifted upright, but it's not enough energy to tip over the second domino. That second domino, because it weighs more and it's bigger, it requires a little more energy in order to get tipped over. But how much energy does it really take in order to tip something over? Sure, a regular domino can't knock down a huge one, but could a regular domino knock down one that's only slightly bigger? Try it yourself if you can. You can use books if you don't have dominoes.
All right, if you're able to try it, you can. We're going to see what happened here. So it was able to do that with a slightly bigger one. So it worked. It had just enough energy to knock down the next one. All right, let's see this next one.
How much energy does it really take to knock something over? Sure, a regular domino can't knock over a huge one, but it can knock over one that's slightly bigger. Other people have noticed this before and wondered, what if each domino you set up was just slightly bigger than the last one, like this setup you see here? Now, do you think a small domino could be used to knock over a really big one? This is a science teacher who's tried. Now look how he's got it all set up here. Are you ready? Boom. Okay, that worked pretty well, but could we do something more impressive than that? Could it be possible to knock down something huge, something as tall as a building even? Let's see what happens when some people tried this. What you're about to see is the Guinness World Record for the largest domino to be toppled over. Look at how big it is compared to these people standing back here. It's not quite the size of a building, but it's at least the same height as a small house. You see this one in the background? Okay, watch what happens when they start with the small domino. Everybody. This huge domino at the end gets toppled over, all with the start of a single domino about the size of a brick getting knocked over. How is that possible? Can you explain what's going on in terms of energy?
All right, so in terms of energy, how do you think it's possible for something the size of a brick to knock something down the size of something a small house? I want you to think about where energy is stored and where energy comes from.
What makes it possible for a small domino to knock down a huge one has to do with stored energy. You already understand that each domino is slightly bigger and taller than the last one, but you might not have thought about what a domino's size has to do with its stored energy. Think about where the energy in each domino comes from. To find where it comes from, it's helpful to imagine going back in time. If we go back in time and watch this whole set of dominoes being set up in the first place, we can see that each domino had to be lifted up by someone. That required that people use energy. As they lifted each domino up high, they stored some of that energy they were using into the domino. Now, for the bigger dominoes, setting them up required a lot more energy. In this case, special equipment was needed, like this crane. Now, it may seem almost magical that a single brick could knock down something the size of a house. But when you go back in time and watch all the pieces being set up, now you can realize the energy comes from the people and the machines lifting each domino. Each domino stores more energy than the last one because each domino is bigger and higher up than the last one. So along the pathway, as each domino is bigger and taller, there's more energy stored in each one. Pushing that first small domino simply releases all the energy stored up along the pathway. Now, this action of one thing causing another to move, and then another, and so on, scientists call it a chain reaction. Have you ever heard that phrase, chain reaction? Why do you think they call it that?
All right, we're actually going to stop there today. So we have just watched that chain reaction happen. And what I want for you guys to do, I want you to head over to your Google Classroom and you are going to answer based off what we just watched together, how you think a brick or a domino could knock over a small building. Okay, so we've learned it just by watching this mystery video. You should be good to go. Make sure you think in terms of energy and write your answer in terms of energy. All right, guys. It was so fun learning with you today. Talk to you later. Bye.